Ladies and gentlemen, dignitaries, special guests, it is now time for us to get started. Welcome to day 3 of the National Space Conference. It's an honor to be with you in your company today. The theme is all about space science and innovation for sustainability. Now, I know the program says Director of Ceremonies Dan Matsapola. He couldn't be with us, so they asked me to stand in. You stuck with me for today. So welcome. It's a pleasure to be in your company. Yesterday was day 2. It was all about the economic impacts of space technologies. Today is day 3, and it's all about space in the future. We're going to be spotlighting the environmental applications of space technology, showcasing how space science can contribute to environmental sustainability. My name is Maud Nale. I'm honored to be your Director of Ceremonies today, but I'm also the Director of Time for those who were not here yesterday. It's such a precious commodity. We're already running late and I am not in a good place. So I'm going to try my level best to recover some of the time that we have already lost. I'm going to introduce our speakers shortly, but for those who were not here yesterday, we're going to follow the traffic light format just to keep our speakers honest for time this morning. When he or she sees the green, this means he has 15 minutes, he or she has 15 minutes left in the presentation or in the panel. The yellow is going to mean 10 minutes, I will raise it. And then at 5 minutes, I'm going to make my way onto the stage with the red. I know in South Africa, at the traffic light, red means go, 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 you idiot. But today, it's going to mean please stop so that we respect the speakers that are following. Thank you so much to all the speakers and the moderators for respecting time today. We are already a little bit behind time, but we're going to try our best to recover as the day goes. The session is meant to start with plenary 2, but there's been a little bit of an amendment, and you see a gentleman up on stage. He is the chairperson of ICASA, and he's going to be spending a few minutes telling us about a proposed new licensing framework for satellite services. Please join me in welcoming onto the stage Mr. Motibi Ramusu, chairperson of ICASA. Over to you, sir.
Thank you very much, Program Director, and good morning to the generals, colonels, and colleagues, profs, doctors, and to the youth of today. As introduced, I think she missed a little bit of my surname. It's Ramusi. So I just thought maybe just to correct that one, but it's fine. Thank you very much to the organizers. I know that this particular meeting or summit is a very important event for South Africa and for the world. And I think for ICASA to be here, it's an honor, especially for those that don't know who the authority is. It's one of the most relevant authority for the work that has been discussed since Monday. Without the authority, I think anything on space wouldn't be possible because it starts with frequencies before you can even build the networks. So I think the relevance of us being here, it's actually important and it's aligned to all the themes that we've had since Monday. Where do I point this? It's not going. It's not rolling. Okay, it's rolling now. Thank you very much. I'm with Councillor Zimbri here, and some of our colleagues should be in the midst. Just a little bit of who ICASA is. This thing is playing games. It's taking my time. Okay, thank you very much. Yeah, as indicated, delegates, the Independent Communication Authority of South Africa is the only official regulator in this country that regulates the telecommunication, broadcasting, and postal sectors. So in short, any one of us in this country who's got an appetite to provide services that will connect people, broadcast, or provide postal services, one has to approach our institution for a process that is being prescribed on how we assign frequencies and how we allocate licenses to those that have got an interest in the business. It was established in 2000. It was a merger between the former IBA, which is the Independent Broadcasting Authority. It was focusing mainly on broadcast, and SATRA, which was more on the telecoms. So jointly, they form what is known today as ICASA. Now, in terms of the mandate, as I've indicated, there's one important document which is called the Electronics Communication Act. Now, the Act prescribes processes and procedures on how one should interact with the authority. Now, for this type of a summit or a conference, it becomes important that for the current and the future, it's going to be important that anyone who provides services in this country, there are rules of the games, and those rules stipulates one other amongst people that needs to participate in this sector. And any organization or an entity, it has to reflect, amongst others, participation of historically disadvantaged groups, women, people with disability. So I know that in the space sector, this has been a high-tech environment, but as a regulator, one of the things that we are going to be encouraging, or that we've been encouraging, is inclusion, especially for the young and the women and people with disability. So as a regulator, those are some of the elements that we look into any of the players in the three sectors that I've indicated to you earlier on. One other important issue is once licenses are issued, one has to make sure that you comply to the license conditions. Imagine now that in space, if we allow any of the space operators to have a footage in our country, and you've got ground reception stations that are not licensed, they are not type approved. I'm sure that, especially in the safety and security cluster, we cannot allow any unauthorized operations to happen in this country. The geospatial Earth observation environment, it becomes important as well that for any other equipment or technology that is being deployed, one has to go through our institution to get the type approval and to get the appropriate spectrum to provide those services. Now, our objectives as an authority, we recognize that we are living in a world of competition, and I'm glad to see that we've got some of our colleagues from the continent. We are talking of collaboration. Collaboration, to a large extent, help us to make sure that we even promote competition. As we know, space, just like internet, doesn't have borders. When one launches any of the beds up there, the only way to manage and maintain the borders is through appropriate spectrum. So competition becomes one of the issues that we need to promote as an authority. And what, again, it's to make sure that for stakeholder engagement, like as we are doing here, I must compliment the organizers, as I've indicated that if the authority is not here to guide, we don't want people to say that I'm doing this, but I've never been advised. So this is one of our responsibilities, to come and educate all of us here to say, when you've got any appetite in this sector, where do you supposed to go? So ICASA is that institution. Now, the customer experience, colleagues, it's very important. I mean, to date, there are a lot of services that are provided, whether it's terrestrial, space-based. We need to make sure that we safeguard, one, issues of security, quality, and cost. That's what the authority, amongst others, we're right now projecting. And in terms of building satellites, that whole value chain is to make sure that in partnership with other institutions, all people of this country are involved in developing the very same sectors that I've indicated, including some of our rural communities and underprivileged people. Now, lastly, which is very important for this summit as well, we have recently published an inquiry document which literally talks straight to what we've been discussing since Monday. Recognizing the fact that things have changed, we are in a mode of accepting new technologies. There are a number of emerging applications that are out there. As an authority, we saw it fit that given the fact that most communities, including sectors, Internet of Things becomes one of the commodities where information is gathered. There was a time when you deploy satellite services, you've got VSATs, but as we know, some of the VSAT infrastructure days are numbered because now there's a multiple type of receiving signals from satellites. So this particular inquiry is going to give all of us here an opportunity just to engage with the authority to say, what's new out there? how should we now treat new licenses? We've got new constellations of satellites. It might be a new thing, not only for South Africa, but for the continent. How are we supposed to manage issues of cost? The very same antennas. If a VSAT, which was a unidirectional, now it's bidirectional, how are we supposed to manage that from a regulatory point of view? So I'm encouraging those that are actually actively involved in space, take advantage of the work of the authority. And as I've indicated, it's an important process. We need to include our own communities, and especially for the youth that are attending here, the future, if it's not informed by user requirements, we don't want to have a regulator in South Africa that dictates. So hence, this kind of interaction becomes very important. In closing, I am actually going to wish all the space community members the best, and I'm calling upon you that we are based in Centurion, in Echo Park. So if anyone doesn't know where the authority is, please, I'm still here, Councillor Zimbri is here. It's our authority in this country, and as I said, without ICASA, I'm sure this wouldn't have happened, because it started with us availing this air and say, you know, build what you need to do, but you must comply to the rules of the game. So that's the 5 minutes that I was given, just to come and lay a foundation that for those that didn't know who the authority is, be comforted that South Africa, we do have an institution that is taking care of business needs, community needs, and we're looking into the future and the relevance, and we don't want to stifle the industry. That's why consultation becomes very important. With those few words, thank you very much. This has been my remarks. And before I conclude, can I just ask all men to stand, all men, with due respect. I know generals are there, with due respect, just for today. All men, I think let's just look at our women and recognize them to say that happy Women's Month. It's the last day today. Let's continue to give them. Thank you very much. Thank you very much. Thank you. We may be seated. Thank you.
Thank you very much to you, Councillor. I didn't get that part. Apologies. Councillor Ramusi, Chairperson of ICASA, who was explaining a bit more about the proposed new licensing framework for satellite services, representing ICASA. We're now going to kick off officially with the program, which is the start of the plenary 2. It's all about resilient space-based communication, navigation, and security systems. And in this session, we're going to be examining how crucial, reliable, and strong satellite communication and navigation systems are for emergency response, infrastructure resilience, and disaster management. Now, leaders are now on the program, at least the physical copy, it says the moderator is going to be Major de Villiers. There has been a change to that, and I'm now going to introduce the revised session moderator, Colonel Zama, who will be moderating the session. It's going to be 90 minutes. I'm going to hand over to you, Colonel. What I noticed yesterday before you come on stage, maybe this was just my observation, when the leaders were speaking from here, there was a session, the first one, where they didn't get to come on stage. They sat there and they spoke. I don't know about the people there, but I was sitting there and we couldn't see. So if you're going to be speaking or you're not going to be presenting, can you maybe just come onto the stage for your introduction? Then later you can go on, just so that people can put a face to your name in the first instance, and then you can go back on stage. Because I realize some people are presenting, but some people are just going to be speaking. Thank you so much, Colonel Zama. 90 minutes, over to you. General de Villiers, ma'am, permission to continue. Thank you. Thank you.
Good morning. Sanibonani. Ninjani. Ngajabula ukunizwa. Siqaleni kanjalo. Siqale ngomhlangano wethu. 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 Siqale ngomhlangano wet All right. Without any further ado, Major General de Villiers, Chief Director, Air Policy and Plans, Industry Chief Directors, our international, continental, regional fellows who have joined us here today, directors, both military and civilian, executives, industry and academia partners and stakeholders, senior officers, ladies and gentlemen, scholars, educators, welcome, and all protocols observed. Okay. I have the honor this morning of having been very, very nicely thrown under a steamrolling bus. I thank you. This podium is not meant for short people. It's a discrimination in and of itself. I have the honor of being your moderator for plenary session 2. My name is Colonel Makamnandi Sindisiwe Zama. I am an Air Force pilot, and today I will be leaving my Earth-based self and joining those stellar constellations out in space and diving in with the rest of you on what is possible for our future space selves. Today's not about me. I am joined by a very austere panel. So I'll run through a brief introduction just by name and title of our panelists here today, and then I'll hand over to themselves to give us their initial introduction of who they are and where they're from, as well as the topics or their area of interest that will drive our discussions today towards a more resilient space plan and infrastructure, and what that means for communications, for navigation systems, as well as for our ability for early alert and disaster management and preparedness. So joining me today in some form of order, I've got with me Mr. Khabo Matapo from Mutsene High Tech Space. Next to him, so from my right to the left, your left to the right. Next to him is Mr. Zane Cleophas, the AMD chairman for their space committee. After him is Mr. Biko Mananga. He's the impact area manager for CSIR. And second to last, we have Professor Evans Ojo. I skipped your middle name, Prof. I'm going to have to warm up to it. Okay. From the DUT. And last but not least, we have Professor Jean Piton, Aerospace System Research Institute at UKZN. Gentlemen, your 3 to 5 minutes begins now. Yes, please, sir, as Ms. Maud has directed, to the podium.
Good morning, ladies and gentlemen, and all protocol observed. My name is Khabo Matapo from Mutsene High Tech Space. Mutsene High Tech Space, we design and develop communication systems such as GNSS radio occultation receivers for weather prediction or weather forecasting, and space weather monitoring, AIS and VDAS for maritime monitoring or communications, RF and microwave subsystems, satellite TTNC transceivers, and radar subsystems and inter-satellite links transceivers. So today mostly, I was going to present about the GNSS radio occultation receiver that is being used for weather monitoring or forecasting and space weather monitoring. So the system, it uses, take leverages of the GNSS constellation like GPS, Galileo, which is already the infrastructure that is in space. So instead of putting our own transmitters, we use those signals from the GNSS. And then we put the receivers that we design on the low Earth orbiting satellite, so that when the GNSS signal travels through the ionosphere and the atmosphere, when it encounters the changes in the atmosphere, that signal refracts, just like the light when it refracts through the medium, that's got different refractive indexes. And then from those perturbations or diffractions, we're able to extract atmospheric parameters, which are needed by the meteorologists and the space weather, to be able to ingest into their numerical weather prediction models to perform the weather forecasting. So we know traditionally the meteorologists, they use radio sondes and radar, which sends the atmosphere from bottom up. But the GNSS radio occultation is an active limb sounding system, so that it does not sound the atmosphere straight like Nadia down, but either limb. So the satellites, when the GNSS satellite is on the other side, and that signal, as it encounters the perturbations, it's diffracted. And then the LEO satellite, when it comes, either it rises or sets, can be able to trace those signals and then take the measurements of those signals. We put in two receivers. One is the precise orbit determination, and the other one is the one that performs the science. And then we fuse that data to be able to extract the atmospheric parameters like temperature, water vapor and pressure, and then and the way we extract it is that those signals, as they diffract, they are delayed, so a Doppler is introduced in there. And then subtracting the normal Doppler, we're able to extract, the excess phase or excess Doppler. And then from the excess phase and Doppler, we're able to get the bending angle, because that signal is bending. From the bending angle, using inversion methods like Abel transform, then we can be able to extract the refractivity of the atmosphere. And then it will have a part that is part of the ionosphere. And that one we can reduce it, because, GNSS or GPS transmit, like there's L1, L2, L3. So for those signals in the ionosphere, they are not delayed the same. So we're able to use, mathematically subtract the ionospheric component. And then from the ionospheric component, we can be able to measure the electron density, the TIC, total electron content, which we can supply to sensor space weather. And then from there, using the inversion methods, we're able to extract, all those atmospheric parameters, which can be given to the climate change, the climate scientists, meteorologists, to be able to ingest them. And the advantage of the radio occultation receiver is that it's very precise, because it uses the atomic timing from the GNSS signals. So it's very accurate. They call it the most stable, thermometer in space. And it's independent of of clouds. So we can take the measurements day and night, and it's global. Because the problem is that with the land-based, radio sonde, ion sonde, digisondes, they are land-based, so they are limited in range. And a lot of cyclones, and storms, like we know today we've got floods, cyclones, climate change and all that. A lot of cyclones, they take place, their genesis is in the sea, around the equator, in the middle of the sea, where there's not measurements. So GNSS radio occultation is able to measure, and we can be able to detect. It's the beginning of the cyclones. They call it cyclone genesis, And then we can be able to track it even accurately. So the system does not replace the ionosondes, it compensates it and reduces the errors, when in weather forecasting, so that we can have accurate weather forecasting models. So we're developing this system, and we're going to prototype it. We're at the moment in the signal processing part of it, so we'll be prototyping it, and next year you'll see it displayed in our National Space Conference. Thank you very much.
Thank you, sir.
We look forward to next year. Mr. Cleophas.
I think at the risk of going through this entire list of protocols, I just want to say a blanket good morning and everybody's welcome. So over the last couple of days, I had this thing planned in my head as to how I'm going to present this program of action that the aerospace, maritime, and defense industry has put together over the last 3 to 4 years. But the more I realized, when I went back to the AMD stand and I interacted with the marketing people, I realized that more than 80% of the people that attended from day one had no clue who's the AMD. So I thought I'll start off with a little bit of a glimpse of who the AMD is, the aerospace, maritime, and defense industry, mind you, the only recognized one in South Africa. And I'll explain a little bit of the ecosystem, and then I'll give you a glimpse of the program of action that we are looking at, and why the alignment that so many of us spoke about, why the synergies we so spoke about, and the public-private partnerships becomes critical. So I'm not going to do this college style. I'm also a former Air Force officer, so, so I'm not going to do it the college style. However, I'm just going to run through it, and using Slido, I'm sure there will still be opportunity for questions, and we can take it from there. So the aerospace, maritime, and defense industry is essentially is the apex ecosystem to ensure a smooth and successful transition within the, well, this much spoke of 4AR. And in the military terms, we added the command portion, the surveillance portion, and the aerial portion of it as well. And then we can now, and so by the way, I'm not a speaker that speaks slide to slide. So I'll make it up as I go along in order to condense this conversation. So without technology being developed by the industry, we will not transition optimally through through these waves. I think it was General Matabula that referred to, was the speaker before him the other day, that referred to this fifth wave, so to speak, and that is using big data sets coming from satellites in order to harness sovereign data eventually, and then ultimately use that for, let's call it the greater good, but also for the purpose of planning adequately, dealing with disaster management, dealing with a whole host of issues. But also it becomes not just a sovereign capability, but it becomes also a capability that determines our political agenda and our geopolitical stance eventually. And I don't think we've even touched that, and by positioning the aerospace, maritime, and defense industry, and ultimately all the programs and subcommittees under that, I believe we can definitely attain this. This portion was taken out of the aerospace and defense master plan. I'm sure if you're familiar with the aerospace and defense master plan, you must have seen glimpses of this ecosystem. So who is the AMD and SAMDEC, which is essentially the South African Aerospace, Maritime and Defense Export Council? We essentially made up, it's a voluntary membership, the only membership recognized by the defense industry, as I just said, and also the government entities. And we are looking at obviously driving local economy in terms of manufacturing and essentially the exports thereof. So the growing of export volumes in terms of value, the growing of the export base, diversifying export base, and diversifying the export markets. Now, that having said that, it can only happen if we have a test ground. Everybody that sits and develops technology of any kind, the first question gets asked, where have you tried this? Where have you developed this? And is this sustainably developed? So we are governed by a board of directors. I'm also happen to be on the board of directors. And subsequent to that, we also have an executive chairperson and the CEOs of various large defense industries. This is how we configured and where we play roles in. We are the South African Maritime Defense Industry, the Export Council. And under the Export Council, there's a whole structure that runs it, the Defense Industry Funds that's meant to help you when you, so in order to execute, tangible orders, the Defense Industry Council. I think a few people would know the Defense Industry Council that is chaired by the Minister of Defense, and ultimately the Secretary of Defense is the accounting person sitting there at the council. Then we got the Sector Council, which looks at the transformation of the entire value chain in the sector within the aerospace, maritime, and defense industry. We've got the AAD that I'm sure everybody is very familiar with. And it's sad to say that not more people is hyped up around this AAD that's coming up within the next couple of days. I think the countdown was referred to at, I think, 19 days. Anyways, the CAV, etc. I'm being told here by our commander that I need to speed up things. This is we need to end things. So these are the
not an individual presentation.
and we'll get into all the content with the back and forth, my good sir.
Yeah. So I'm about to conclude here, Colonel.
Perfect, thank you.
So the defense industry ecosystem, I'm not going to run through that. We can look at the slides later on. This is some of our membership. You can also look at it later on. We've got the marketing material. And then our program of action that we were looking at. This is some of our export clients that we're looking at. And our program of action, obviously, we spoke about strategic industry partners, public-private partnership, international collaboration. I'm now speeding through this. I'm pattering, Colonel. So the alignment of the national goals and the SADC objectives is closely aligned to that of, first and foremost, our primary end user that sits within the defense or the National Defense Force in South Africa. Then there's the policy coherence issues and also the compliance in terms of international standards. The aim of this all is to look at optimizing existing infrastructure. We spoke extensively about, the space and everything surrounding the space technologies, etc. But we omitted key things, and the key things are how do we leverage from what we have now? Things like Overberg, the Air Force Base, as well as the test center. We've got Hartbeespoort, we've got Mikersfontein, Houtec. Now there was Blimpses referred to it as well, but we should delve into it and how do we optimize that aging infrastructure and how do we get investment funding going in order to do that. These are all industry initiatives, and we hope that with this bit of a glimpse, we are able to bring everybody together and surely look at an alignment strategy that will service the need of industry first and foremost, but also our political objectives, by that meaning where we are going to in this, and let's call it the 5th space race. Thank you, Colonel.
Good morning. I'm Biko Mangaga from the CSIR Defense and Security Cluster. I'm heading the Aerospace Systems Impact Area. We operate as an in-house science and technology capability of the Department of Defense and also the Department of Science and Innovation. We do so by developing and maintaining strategic capabilities to support a ready and able defense muscle and also a capable state. We provide technology solutions through research and development to enhance existing capabilities. And also, we do collaborative technology development, leveraging the local space industry. In our journey to space, we seek to enable a vibrant South African space sector by enabling South Africa to participate beneficially in the rapidly growing space economy. That is for industrial, social, security, and also for economic impact. In the National Space Conference last year, the Chief of the Air Force, Lieutenant General Mbambo, announced the completion of the feasibility study, which he tasked the Space Command Integrated Project Team and the CSR to conduct, which has set forth the announcement he made on day one of these proceedings. That is the approval of the required operational capability by the Ops Command. And that is the development of development and launch of a satellite as a foundational mission to support the establishment of the South African National Defense Forces Space Command Sector. So this will see future satellites provide defense operations and enhance capabilities in communications, surveillance, and reconnaissance. So these reconnaissance satellites will utilize a range of sensors to achieve this, and this range of sensors are sensors that are already being developed by the local industries, including ourselves. This includes high-resolution optical cameras, synthetic aperture radar, which was widely covered yesterday in the technical sessions, and also automatic identification systems enhanced by the video data exchange system receivers to monitor maritime traffic and also to support the search and rescue operations. And also electronic support measures receivers to detect and locate radio frequency signals. So the dual use of these military space sensors speaks to the broad mandate of the South African National Defense Force, which includes disaster response, border security, and regional intervention. So derived services from these space assets are growing rapidly and is disrupting a wide range of industries and sectors. This includes the defense operations as well. So the space supply chain, which includes the launch vehicles, satellites, satellite components, and also ground systems, is a huge and rapidly growing, very high technology industrial sector. And SA, South Africa, currently has a small but a competitive upstream local space industry, which are developing components, payloads, and small satellites, and also we are securing exports in global supply chains. As we know, access to space is secured by means of space launch vehicles, and then many of these space launch technologies, they overlap significantly with other aerospace technologies that are already developed. But we need additional advanced technologies which include liquid rocket engines. So with access to space, sovereign space capability can truly be achieved, can be established, including resilient communications. So resilient communication systems, they offer encrypted high bandwidth channels that are resistant to jamming and interception and critical for maintaining command and control, most especially in contested environments. So as the CSR, we're involved in steering committees supporting the government in its goal to make South Africa a space-faring nation. This includes the tech and infrastructure subcommittees. We participate and collaborate with industry and government in space-related research and technology to increase the capability of the state. We are supporting the Department of Defense in establishing its space capability. And lastly, we are supporting the Department of Science and Innovation and SANSA with establishing the indigenous launch capability. Thank you.
It's my first candidate to give that man a bells.
Distinguished guests, ladies and gentlemen, good morning to everyone. And it's not pretty. Did you load it? Yes, I did. Good morning once again. My name is Professor Evans Eshemuge Ojo. The moderator actually said he couldn't pronounce my middle name. It's Eshemuge, meaning God makes you a king. I'm the director of DUT Space Science and CNS Research Center, Durban University of Technology. This is my staff. Because of the mandate or the instruction I was given by the moderator, I will be very fast in my presentation. This is just my, should I say, my team, my colleagues that we are currently working together. I want to use the opportunity to invite interested parties that we will be hosting the 3rd Space Science and CNS Symposium on the 31st of October 2024. And you are all welcome to grace this occasion. This is our collaborators. We have DSI, SANSA, ATNS, and others. These are the various collaborators we are having. And I want to also use this opportunity to also invite collaborators because maybe in the next, should I say, symposium, I should be expecting more collaborators in this slide. Please, you are highly welcome to maybe contact me in area of collaboration regarding to space science. This is just to tell you how space science DUT was actually formed. It was actually the mandate from the Pan-African University for Science, where some 6 universities was given the mandate. DUT, UKZ, and KPLSA was given the mandate to work on the area of space science. This is some areas of research. Because of time, I will not go through any of them, but this is the area we are currently expanding on. And in terms of collaboration, we can actually collaborate regarding to some of these areas. Our main area for now, that's why I was giving this, should I say, this area of a presentation. We are currently researching on communication, navigation, and surveillance, which is the concept of, that is actually being taken up by the, should I say, ATNS, and they get their regulation from the International Civil Aviation Organization. Based on the title of my area of, should I say, discussion today, which is actually dynamism challenges in positioning and the need to continually expand or, should I say, improve on the CNS. One of the things we should know that aviation is dynamic. And from physics, anything that is dynamic is always a function of space and time. And meaning it's not static, meaning there's a need for time to always, should I say, review and improve on the system. I won't go through this, but these are the mandate of what I'm going to say, things that the CNS, the ATNS actually perform. But one of the things we should know that this trend, if not taken care of, which is the dynamics in the aviation space, this trend tends to ruin the navigation system input and fuel capability of equipment. Hence, it's necessary to use more advanced. This actually enhances some of the information that was being given to us by ICASA this morning. The challenge in the space, for the past 2 days, we have been talking about expansion of space in Africa. It's like making complex system to be more complex. But this brings about some challenges, and some of these challenges are highlighted, which I'm not going to look through. There's a need for improvement because we know that aviation is safe, but there's new trends that are coming up these days. One of those trends are things like, what's it called, performance, it has to do with things like cyber attack. This is supposed to be before. This has to do with cyber attack, threats, and other, should I say, things that are being, should I say, perpetrated by cyber criminals these days. Because of that, there's a need for us to continually improve, which I believe one of the, should I say, the function of ATNS to actually carry out for our, should I say, aviation to be more safer. These are our expected benefits. We will expect that if some of these, should I say, using of some of these, should I say, technology, AI, machine learning, if some of them are being put in place, we will be able to increase the future-proof technology performance for airspace users and operational environment, and improve spectrum efficiency, knowing that spectrum is very scarce and expensive. Support innovation in terms of performance, positioning, security, and aspect. This will help to achieve interoperability outlined in the ICOA, is the last, in the ICOA navigational plan. Thus, we can help to enhance ability operation efficiency in space, cyber to prevent, detect, and counter response to full spectrum. Thank you. In case of this, my details. Thank you very much.
Colonel, firstly, thank you for the earlier introduction, and I must say I find your cutthroat moderation style pleasantly refreshing. So, thank you. Good morning, everyone. I'll get straight to business here. Don't have much time. And I'll start by making two statements. I've written them down. I don't want to make a mistake as I reflect them. So here we go. First statement. Full attainment of national security relies on achieving sovereignty across the entire space capability spectrum. And from, you can clap. and you know, from ASRI's context, the second statement reads, a fundamental element of a sovereign space capability spectrum is indigenous space access. And that's exactly what, much appreciated, thank you. That's exactly what ASRI is striving to do, to build indigenous human capital, indigenous technology, to deliver an indigenous space capability. And on that note, the important comment to make is, if South Africa is serious about indigenous space access, we need to do it indigenously, right? Not relying too extensively on foreign partners. In the context of national security, that's critical. All right, I'm going to work very quickly here because I've already taken too much time for the introduction, but effectively what spearheads our efforts is the development of a small satellite launch vehicle we call CLV. And CLV is interesting because it's really designed for commercial applications, for servicing the commercial small satellite launch market and dedicated launches, but it allows a range of payloads to be accommodated if we fiddle a bit with the configuration of the vehicle. So on the left-hand side, CLV 1.0, which is what we're working on now, and that has the capability, estimated capability of around 250 kilograms to 500 kilometer sun-synchronous orbit. Right, if we modify that and kind of come up with what might be referred to as a CLV heavy, as shown on the far right there, CLV 1.2, by incorporating 2 additional booster sections, we're now talking 600 kilograms to 500 kilometers sun-synchronous orbit. So effectively, what we're excited about is CLV technology covers what we would imagine to be all of South Africa's defense needs, for example, for defense payload lifting. Key to the CLV vehicle is the Sapphire rocket engine, which we're currently developing. On the left, you see basically a rendition of the first ground test engine that we tested earlier this year in June at the Overberg Test Range. And on the right is the latest design configuration for the first flight weight Sapphire liquid rocket engine we hope to test around the second half of next year. So in case you didn't see it, I'll just show you a video summary of some of the testing we did at the Overberg Test Range in June. CLV will use 9 of those engines on the first stage. It's going to be quite a spectacular sight. 2 final comments to make about capabilities we're working on. The next is suborbital space launch. We're very proud to announce that in December, we expect to fully commission a suborbital sounding rocket launch gantry developed by, under ASRI's direction. And that is going to allow us to be launching NASA sounding rockets, ESA sounding rockets for local scientific research in the Southern Hemisphere. And we're also working on a very exciting project called Steve, and Steve's a suborbital launch vehicle which is going to test the Sapphire engines and reach space, which is really exciting. And then finally, we started a very exciting program this year on green propulsion, in-space propulsion. So we're working at quite a rate on that. We've already made our first batch of fairly sophisticated green propellant, and we're going to be testing a version of the thruster you see in the middle within the next 2 months at UKZN. So with that, am I on time? Oh, beautiful. Perfect. Thank you.
Okay, gentlemen, thank you very much for those opening remarks. I think some of the key items that we all gleaned from that will start with the fact that while there's a lot going on in the space environment, our ability to really benefit from it has to do with the system being able to be sustainable, to survive, and in order to support some of the technology that's coming through. And some of the key things that we noted are that we require some good regulatory framework and support from the regulators. The resilience items that are coming through in the opening statements is that we need the provision for stability. Security is a key one from both man-made and natural disasters. We also need to look at an indigenous offering that is key to our resilience for the space system. So these are quite important aspects, and I thank you for those opening remarks. This next section of our panel will go into the question and answer, and what we posed to our speakers, and they will each get an opportunity to speak on, were the following questions that speak in and around the resilience of a system. It goes without saying that it is crucial. The resilience of our space futures is crucial, so that is not in question. The importance of the system is not in question. What we would then like to step forward and look into and focus on is what is an attainable space resiliency? What can we here for our own indigenous provision be able to state as enablers for our own resiliency, and be able to then generate a standard that will satisfy all our players, both military, both governmental, the industry, and academia? Can we arrive at a shared state of an acceptable resilience standard? And how do these individual offerings, will they be able to support that? And how would that standard look from the perspective of the academics, from industry, from the tech innovators, and as such? Secondly, we'll then look at, with all, and this is a bit of a white elephant, second broad question, we have a lot of earth-based issues as it stands. With all that we have, and there have been some good developments, and there have been some advances, but there have also been some retractions in certain aspects. Do we not run the risk of looking forward and aiming to space and missing the ground meeting the stratosphere? So how do we bridge this gap? Is our space intentions a bridge too far? Man, you owe us. We have a rule where I come from, phone goes off in a session, $100 in the pot. We'll buy each other coffee afterwards. Okay. All right, that's our second broad approach. And then lastly, we obviously all come from different aspects and we have different requirements. How do we bring all these requirements together to make sure that we are not running in 6 different directions, and that we are optimizing the resources we currently have, we are leveraging, and we are using it to keep with the space race, instead of all of us running in parallel and completely missing each other? So those are just broad topics. I invite the panelists to ruminate on those. They already have. And we'll run again from my right to the left with your offerings. In conjunction with this, we will have Slido also speaking to us. I believe you can all see. And while the panelists are speaking, feel free to have a look at the questions being posed. If they speak to the element you are addressing at the time, feel free to pick it up. Otherwise, after the set question session, we'll open up to take questions from our viewers. And shout out to all our viewers who are watching this on live stream. Special shout out to Lababagwa Mashu. Thank you. All right, so Mr. Matapa, if you could start us off.
Okay.
What does our resilience baseline look at? Keeping in mind that we are particularly interested in communications, navigation systems, and national security. So what is the baseline that we should be looking for to satisfy all of us?
Okay. Thank you very much. First, I would like to say, since I was young, I've always had this in my mind: why does Africa, have to depend mostly on European and American and foreign satellite systems, that's in communications and in navigation systems like that. Because once you depend on someone else, if foreign case security-wise during the war, they can always buy you from their GNSS systems, and today we know that things like wars, as the one in space, you need that position and navigation and timing, which is very, very, very critical. And that's why us at Mutseni High Tech Space, we design and develop these systems. We started with GNSS, because I've always loved reverse engineering subsystems, so that I can design them and build them. So I think we need to move in that direction, of developing our own systems, some of the navigation systems, so that we're not just reliant on foreign navigation. Of course, first you have to start with what you have, which is what they have, but at least build on that, so that you can have your own systems that will be resilient and you don't have to depend on someone else. Thank you very much.
Thank you, Mr. Matapo. Mr. Clearface.
I think in line with, and I think the Prof highlighted it very nicely. I know I was speaking at the speed of light, but it is exactly what I was trying to convey. When I spoke about sovereign data, I spoke about not per se indigenous capabilities, but that's exactly why the AMD, from an AMD perspective, as the Associate Defense Industry Association, everybody that sits within the ecosystem has something to do with the defense at some way or other, and it's no longer defense, as they would say, that makes katang. It's dual use for multiple purposes, whether that is in resource planning, whether that is in utility planning, and I think, latching on to my colleague to my right, it is critically important to have, first and foremost, your own capabilities, but build on home ground. Because in recent, I was told in Zambia, some of the Western powers just confirmed that's one of the biggest funds of copper, for instance, and that was highlighted through satellite data. And so the list can go on. The same with troop movements, the same with, all these kind of things. And unfortunately, if you're at the mercy of someone else, you get switched off. I don't want to name names, but for instance, in the aeronautics environment, a certain big manufacturer just refused to give parts to specific countries when it comes to service and maintenance of aircraft. Now, the same goes for the space environment as well. And I think there's a big applause that goes out to all the industries that has been working very hard to do that. But I think the old African saying that if you want to go alone, you can go fast. But if you go together, you can go further. And I think the alignment is critical in order to achieve, the sovereign capability, indigenous resource planning and development, but more so the security aspects. Thank you.
Thank you, Mr. Clearface.
I fully agree with the response that Zane has provided. And I would also like to approach it in two ways. Space-based resilience, it starts more on the understanding that the assets that are in space that provide this vital communication need to exist and need to have a protection. So if you have assets in space, but you subsequently find that somebody else knocked them out, then you are completely terminated and cut off from making use of those assets. So there is a need, which is a bit futuristic, but I think it has now been shown that there are certain state actors that seeks to disengage other nations' space assets, satellites, so which then seeks to have a need for a country to look into how do we then have space assets and be able to make sure that they survive in space. That is number one. And number two, or more specifically on communication, I've already in my introduction indicated that techniques such as encryption of bandwidth channels, high bandwidth channels, it is one of those things that are critical to make sure that at least you can have a communication that is continuous to have your continued mission. In the CSIR, we have Information and Cybersecurity Center that develops these techniques and then make sure that they stay up to date and making sure that we have the ability to encrypt these channels and then have a safe and secure communication networks. Thank you.
Thank you, Mr. Mananga. Professor Eshemogo Ojo. You see, I'm warming up to it.
Thank you very much. From the academic point of view, I would say that the resilience concept can be looked at from some of the inference that we have drawn from this conference for the past 2 days. I remember the first day somebody brought about the, should I say, the word of space science in terms of budgeting from all walks of life. It tells you how much or how huge this sector is. And secondly, when you also look at what we call technology, I will give some examples. I'm into computing. There are some areas that have to do some kind of, should I say, numerical modeling. I will approach somebody from a country. He will tell me, I will give you the software, but I'm going to keep the server. Then I ask the person, what am I going to do with the software when the server is not there? This goes a long way to say, if he gives me the server, I will not go to him. And definitely I have to depend on him because we are talking about money, because I have to buy the license and so on and so forth. It tells you if the server is given to me, automatically he is rendered not useful to me anymore. There's a concept that I always put across that though it's a loose-use word that there's what called technological transfer. I don't believe on that. I believe technological acquisition is the way out, which was demonstrated today because I know my professor sitting next to me actually demonstrated it that you don't have to transfer technology, you have to acquire it, because if you wait for transfer of technology, it will not happen because they need independence. We just have to look at it from the areas that my colleagues have already said. If we really want to really get the resilience and we want to really become really independent in terms of space technology and space science, technological acquisition is the way to go. But there's a question, because we're actually doing research. The question is the time factor. It's like a race. They are really far ahead of us. How do we bridge this gap? Because the truth remains the truth. They will not give us this technology for free. We just have to acquire it. And the problem is, how far can we go? We may collaborate, but how far can we go is the biggest question in terms of technological acquisition. Thank you.
So Colonel Zama, I'll answer the question by asking two other questions. And the first question is how resilient should we become? And I think the answer to that is obvious. We should become fully resilient. The second question, though, is how resilient can we become reasonably? Yep. And that's a time frame question. It also depends on two things. It depends on political will, because government needs to underpin what we're doing as we build resilience. And it depends on financial viability. And by financial viability, I mean whether there's government funding to support major projects, to seed fund new companies, and whether there's commercial viability in what we're doing. So I think, you know, when it comes, speaking from the context of space access, there is profound political will. You know, we wouldn't be where we are today as ASRI if we didn't have the backing of the Department of Science and Innovation. They've been incredible. And that's what is required. From a financial viability point of view, for example, building a launch capability, being realistic, is hellishly expensive. And it's got to make sense. And it can tick different boxes, but those boxes, the value of those boxes need to be accounted for. So ultimately, I'd say political will and financial viability are key. Obviously, human capital development is fundamental. If we don't have sovereignty, if we don't have people, South Africans and Africans who can do the work. And yeah, I think that's where I'd leave my answer.
Thank you very much, gentlemen. I pick up a slight an academic debate, you know, right at the end there, on we're really far behind everybody. So we cannot at this stage want to fully start and develop everything on our own. We need to get into the acquisition game for what is already there, but the question is, how far do we do that, and how far does that balance work with providing and creating our own? Something that will probably be a play for us for quite a long time, something that your various industries will have to answer to without feeling like you're being left behind or you know, being thrown in the sand. So it's going to be quite an interesting challenge. We'd like to develop that argument for acquisition and for own indigenous tech development versus transfer, because the point raised on ITAR restrictions, restricting use, is very valid. We see our South Korean partners going through that very same phase with their American partners, that they're getting heavy ITAR restrictions on what they can do, and they are beginning to branch out on their own. So there is both an opportunity and there is both a cost to this approach. So here key would be to strike that balance of finding it. I'd like to leave it at that. We have some participants on our Slido system. They all got real excited by Professor Pito's demo. There's a lot of rocket-based questions. So we'd like to take 2 minutes just to give them an answer so they feel they're part of the session, and then we'll go back to our broad discussion. So gentlemen, please to your panels. And where the question has addressed a person in particular, I'd like that panelist to answer. Professor Pito, there were quite a few for you regarding the launch of the heavy launcher, the timeframes, the types of fuels and rockets. If you can give us a 2-minute rundown of that system, and members on the Q&A, please, that should then suffice for those questions, and we'll move on to questions on protocols and Captain Kirk's question for the whole panel.
I was hoping to be able to choose just the easiest one, but you're
not a chance.
Asked me to answer a few questions, so I'll stick to the fundamentals. In terms of time frame, CLV 1.0, the original CLV, that time frame, development time frame, depends completely on resources. So whether the project is properly resourced, both financially and from an engineering capacity point of view. Currently, I would say realistically, our quickest time frame is probably 2029 for the first test flight. In terms of CLV heavy, that is not necessarily from a commercial point of view a sensible route to go, but the nice thing about the concept is that it allows us to take technology that would already be developed and enable kind of like a step change in payload mass capability. So it's probably more reserved. It would only come a couple years after initial flights, and it's probably more reserved for very bespoke missions. And then maybe just to answer the question about propellants, we use tried and trusted liquid oxygen and kerosene. We are using electropumps in the engines to pressurize the propellants before they enter the combustion chamber, which is kind of a compromise in performance, but technically achievable here.
Thank you very much, sir. There was a question I noted that brings in a member of our panel. There was a question for the CSR and AMD. What is your level of involvement in the UKZN in Professor Pito's project development? Are you involved? What is the potential for involvement in order to bring together all these various entities? If you are involved, or if you have any intentions of being, maybe this is a nice pitch for you to get involved. Gentlemen, please go ahead.
Right. Thank you for that question. As a CSR, we are part of the Indigenous Launch Vehicle or Indigenous Launch Capability Steering Committee, which is spearheaded by the South African National Space Agency. And that includes the Department of Science and Innovation, which is primarily have been the champion funding the development at ESRI UKZN. And as a CSR, we play a supporting role in all the department's endeavors. So we are part of that steering committee, and we also chair a subcommittee on technology and infrastructure so that to support a successful establishment of the space launch capability in South Africa by 2028 or 2029, as you can have a revised date on that. So we are actively participating in that and to make sure that we support, to make sure that they are successful in their development.
Thank you, sir. AMD?
The AMD's role at this point in time, the Prof is launching off one of our members' sites. So yes, we definitely play a role, but not a big enough role, Prof, and Madam Moderator, because it's more than just launching, more than just creating pre-flight, more than just design, more than just in-flight testing, there's a whole community and an ecosystem that runs for it. You've got an alien community sitting at Arniston that could benefit of this specific, there's smaller companies designing things and doing some amazing work in the telemetry environment. That's members of AMD, but struggle to get that kind of traction. And I think what UKZN is doing under USRI, is a classic example that if we are closer aligned, we can optimize it so much better and getting so much more value out of it. And when people see that it's not just this thing and people driving in and out of a town and coming to stay at a B&B, but they are critically involved in that. And mind you, with a lot of the members are bringing in funding, etc. But then it also allows the community to be involved. It allows, for instance, from an Air Force side, for instance, there's runways that needs to be upgraded. From an OTR side, there's upgrade of telemetry, and the list goes on and on. But you've got an adjacent piece of land that would fit beautifully in for exactly what the Prof and other companies are doing from a testing environment, taking it away from the in-flight testing portion of it. However, that belongs to the local government. And if you do not have everybody aligned, you will have some form of resistance. So from an AMD side, we believe, yes, we are involved, but not enough. And I think this is, case in point, UKZN's efforts that they are doing, which is amazing, could be utilized much better. Recently, we had Glove Cosmos, Madam Chair, if you allow me, that visited OTR, visited Bredasdorp, and how many people actually knew of them actually being there? And they're the civilian leg of Roscosmos. And if we knew that there could be a lot more better alignment between all the role players and stakeholders.
Thank you for that. I think we all echo those sentiments, and they're key to around some of the questions we're discussing. Everyone is excited, but it seems that everyone is working in parallel to each other, and we aren't always working in alignment. So a key takeaway here for all parties involved is that we have to be able to keep those communication links, those networking links, and those shared deliverables and objectives aligned with each other so that we can optimize and leverage what it is we have to catch up in the space race. Okay. Thank you, sir. There was a question I will take from Bomelelo. What are the key challenges ensuring the resilience of space-based communication systems against natural and artificial disruptions? I'd like Mr. Matapo to start us with this one. He spoke quite in depth on the security of both GNSS and GPS communication and the occultation and what they were experiencing in terms of securing that, and followed by Professor Ojo, who also touched on those items. Thank you.
Okay. Thank you. Yeah, of course, there are challenges in ensuring resilience to space-based communication systems against natural and artificial disruptions. But there are mechanisms, for dealing with these disruptions. It could be like you can use encryptions, to avert some of the disruptions. If we're communicating and then someone's trying to disrupt, our communication systems. We can use dynamic or variable modulation schemes like the spread spectrums. We can be able to use those kind of techniques to mitigate, for the disruptions during our communication systems. Because you know, what I wanted to say is that here in South Africa, you know, we've got a lot of capabilities in designing, you know, these communication systems and all these various modulation schemes, you know, we're capable of doing this and can be able to juggle around, you know, all those disruptions.
Thank you very much, Professor.
Thank you. In terms of the question that is posed, we are actively engaging with ATNS regarding the what we call a space-based communication system against natural or artificial disruptions. We're actually working with them. The major, should I say, hurdles now is the IPX, which we are trying to say, in case maybe a commercialized or tangible patent come in, it's DUT or ATNS, that's what we actually, the stage we are, but we are actively working on it. But in what was, because we're actually working from the research, should I say, aspect of it. ATNS has realized that there's a what we call a growing malfunction in human errors and risk from what we call cyber threats. This is a very important factor that is affecting their operation. And they aim to develop like a form of autonomous plane protection that enables real-time threat detections, risks, reduction of flight interference, and ensuring interruption of services. These are various projects we are actively working on. But in terms of your question, if I must go ahead, if I must go into it, we're actually going to take advantage of some of these tools that are already available. One of them is what we call the implementation of AI and machine learning. This will help to speed up the accuracy and also help in the process of, let's say, traffic management. This technology can also help in assisting in predicting potential should I say, threat. We all know this is something that we never look at when, should I say, wireless communication came in. We found out that the more we are expanding, there's always a vulnerability in the system. And what we call a cybercrime, popularly known as hackers, they're not taking advantage of it. Just imagine if somebody can have an access to, let's say, ATNS system and hack it. One of the things they will start looking for is ransom. If not, they will start putting threat. And that is one of the things we don't want to see in the foreseeable future. Based on that, we are looking at security measures in terms of designing principle, minimize risk escalation to enhance resilience of space against cyber threat. That's one of the things we are actually trying to put into place and see how some of these threats can be minimized. There's no foolproof system when it comes to cyber space. If somebody can get access to your, should I say, your frequency and can manipulate it, you are in trouble. But in terms of minimizing it, it's one of the things that we are actually looking at in terms of research area of it, using technologies to see how some of these things can be prevented, if not minimized to the barest minimum. Thank you.
Thank you very much, Professor. While we are on the issue of communications and securing of those communications, there are certain aspects from each of the individual panelists and the work that they are doing that speak to those. I'd like us to spend another few minutes just discussing how this has evolved and how it has developed into something that can sustain itself and support current systems. So I'd be happy to hear, we'll start from the furthest end this time, Professor Pitto, and then we'll work our way towards Mr. Cleophas. If there has been development in these systems in making them more self-sustaining and more secure in your own environments, and whether or not this has been supported by regulators. Now, I don't know if Mr. Ramos is still in the room. He could perhaps help us here with how the regulation has stayed ahead with these requirements. Otherwise, in your own experience with the policymakers, are you finding that there's avenue to grow these systems and make them more sustainable?
I'm really glad you've asked that question, because I think the greatest existential threat, again from a space access point of view, to the work we're doing is that there's no legal framework to permit launches. There's no legal framework to license launch vehicles, to license launch companies, to license launch sites. That's a massive problem.
Yeah.
And that is South African politics is about as lethargic as a sloth. Obviously, we all know this. So we have to get that into gear quickly. I guess that's the extent to which I can answer that question. So I've hogged enough of the airwaves, so I'm going to pass it on.
Thank you, sir. Mr. Mainanga, over to you. The professor has given us his plentiful on the communication security, so I'm going to bypass him this time.
Yeah. Yeah, I think the professor was ready for that question more than I am, so I would like to give it to me.
It's good. I'd like to put you on the spot. Okay, no problem. Mr. Cleophas?
Look, from the membership, I think the Prof gave a nice depiction of this. Is probably and Prof Peter did the same as well. From the membership, the AMD membership, as I said as well, there's a vast array of expertise that's lying around there. But critical to it all, you can make all the plans you want to. If there's two things missing in your plan, which is political will is the first one, and the second part is with that political will you need funding. And in order to get those two done, you lead it from the highest office. I mean, if we look at any space program in the world, it's normally run at an extremely high level, and we see the transition being run from government now transitioning going into the civilians actually heading up, with a melting pot of academics and all those kind of people that's sitting around the table, purely because there's too much red tape that sits around there. Now the security aspect to it is you can make all the plans yet again. You can want to, like we've seen now in recent days. If you get attacked, you will get attacked. If you get ransomware, you'll get it. And the only way to kind of control that, and that is now my counterintelligence mind speaking, and the only way to control that is through indigenous development. If I have control over my encryption keys, if I've got control over my pipe up and down, I will have the ability to basically control who goes where, when. Hence the development of air-gap computers and all those kind of stuff. And in this instance, again, it calls for closer alignment because the scientist that wants to put something in the air and something in orbit is focusing on that portion of it and all the elements in order to get that. But in order to get that, there's a multitude of other things that needs to happen, and that other things is inclusive of dealing with the risk factor. That risk factor is, we spoke about space debris, we spoke about, somebody's asking about, our preparation for solar flares, etc., and the list goes on. Now, you can't have a multi-million-dollar vehicle sent up into space only for it to be hit by a solar flare in the first day. So, and we've seen that happening as well. And this risk register and risk factor is inclusive of the cyber portion of it. From an AMD perspective, what we've now done is we've elevated the let's call it the space agenda to the level of the ministry. We happen to have had an engagement or two over the last couple of weeks, and there's a lot more that's going to be happening over the next coming months, leading up to AAD and post-AAD specifically with regards to alignment within the space capabilities, with the space environment. That inclusive of our security cluster, and we had a discussion with the chair of ICASA as well, that's already crafting his mind, and I don't want to speak on behalf of the ICASA, but it shows the level of commitment from the regulator as well to make this work in a sustainable way.
Thank you very much, gentlemen. Finally, so you would like to go? Please do. That's the one opportunity where we have no time restrictions.
Okay. Yeah, just to add, when they said experience South Africa, we've got the much capability, what I was saying is, like they said, it's funding, of course, from the government, that's lacking, because funding, of course, it just help you accelerate your development, if you've got the capability. When you've got capability and you get funding, then you can produce, the systems quicker. Then we're not that much behind, you know, the developed world, you know. And, you know, of course, on the security side, like I said, we can use authentication, encryption, artificial intelligence, you know. And then I saw one question here about, you know, how do you deal with solar flares? We can put radiation-hardened components. If you got money, you can buy radiation-hardened components or radiation-tolerant components on a system satellite, so that when the solar flares come, you know, they are not affected that much.
Thank you. So you make a point there that for me as an Air Force person, if you have money, some of these things are key to the survival of a system. And the decision we often find ourselves in is this too much money? And if you can't afford it, then it becomes optional. I'd like to put forth, and I'm happy to be corrected, that some of these requirements which speak to the security of these space systems, which speak to the sustainability and the resilience, should not be an option of money. They should become an inherent part of making the system work, because you know what's already out there. Therefore, we need to send out equipment that is hardened, that is prepared for this, so that we support the whole life cycle requirement. So back to the beginning of life cycle, Mr. Ramusi has joined us. He is key in the regulatory framework. So I don't know if you picked up the questions from Professor Pitto and subsequent speakers. If you can give us just a quick 30 seconds on how is the regulatory framework going to support all of these endeavors?
Yeah, thank you very much. Just for the delegates, last year, December, we attended what you call the International Telecommunication Union. It's a World Radio Conference. So what happens is all different countries, because they've identified specific frequencies that will stimulate new economic growth, especially in the space and many other services. So as a country in South Africa, we're in a process of revising our national band plan, which is the frequency band plan. That's one way of now identifying new potential services that will be accommodated in the new band plan. That's the first issue to respond to. But when it comes to policy, I think maybe those that are not aware as well, within the Department of Trade and Competition, Trade, Industry and Competition, we've got the National Space Council. So amongst other things that we need to be doing in a collaborative environment between ourselves as regulators is to find a way of advising our government, I think when it comes to politics, to advise our government to work towards developing a national space program. Now, an integrated program will then take care of not only geospatial Earth observation, navigation, but it brings SATCOM. It's a pity our DCDT colleague is not here, but that would be the best process to engage South Africans to say, if we're looking at expanding our program within space, we need to have an integrated program that addresses various elements within the space value chain. But from a policy, as I said, it requires that, but from a regulation, there are actually now programs that will make sure that those that are doing research, you can come to ICASA, we can avail Spectrum to support some of your master's PhD program, because there's specific frequencies that are available for research purposes. Thank you.
Okay, that was a very popular response. Thank you very much, sir. I think just lastly, we touched a little bit on it while I have you on here. We've covered most of my broad 3 questions. I think we've done a fair amount of justice there, by no means exhaustive, but this is only the first portion of our discussion. I'd like to think there'll be more interaction thereafter and in-depth delving for those sitting here who take what we say with them. But now that we've started on it, we looked at the beginning of the life cycle of this with the framework. Let's talk a little bit about the whole life cycle concept of our space endeavors. This is also key for having a sustainable space system, space program or offering, as well as one that is resilient to change. And one of those being political change, will, economic ability. So if we look at an entire life cycle approach, one of the things that comes from there is how do we account for an environmental impact with all the, what do we call them, vehicles that we are looking to launch into the space in multitudes, with all the micro systems going up there, and with all the different interests. What is your what is your own individual take on all preparation or thoughts on the preservation of that environment so that we can continue and utilize it and not clog it as we're seeing now? Because the reality is, with our disparity in development to the rest of the world, they'll get to a point where, similar to greenhouse gases and things now, regulations are put in place that will impede our further development because it's become another environmental problem out in space. So what are your thoughts and your preparations for your own systems to account for your impact on the space environment? From the far end.
Starting this side.
Yes, sir.
Well, again, from a launch perspective, currently the impact on environmental impact of the launch industry is pretty small, very small compared to the airline industry. But that's not going to carry on being the case. And it's time to really start dealing with the ramifications there. So not just from a pollution point of view. I mean, they're now finding that, for example, the sort of emissions from Falcon 9 vehicles, SpaceX Falcon 9 vehicles, can play a major role in climate warming, actually, if things get out of control. So we need to look at cleaner fuels. And, you know, in terms of our specific case with the Sapphire engine, one of the things we're able to do is, because of the flexibility of the engine, look at using different fuels. So sustainable aviation fuel, while it's a bit of a pariah in certain circles, environmental circles, it's pretty well suited to us because our volumes are low. But we're also going to be looking at other fuels. So yeah, carbon emissions are a very big problem, well, a growing problem that needs to be dealt with. And then from a space debris point of view, it's a mess up there. I'm not very well versed on what's happening in that environment from a control point of view, regulation point of view, but obviously we need some pretty stringent measures in place now.
Thank you, sir.
Thank you very much. Before I go into that question, there's something I would have loved to put across, which could have summarized some of the discussion we have had. One of the things I want to put across is a vision. We found out that if we must succeed, there should be a well-coordinated vision, especially from a forum like this, where we can now tailor it to a specific goal and see how some of these visions can be actualized with time. Consequently to that, I realized that when you are dealing with two entities, the turnaround time is always a problem. Like when you are dealing with governments, because of the bureaucracy of finding that if not possible, should I say the project may not be actualized. But when you are dealing with private sector, you find out that within a short time, they give you the go-ahead to establish what you want to do. Coming to your question, I don't know whether we'll have a direct answer to that, because the greatest polluter of the environment comes from aviation. If you look at what is actually being emitted from the aviation, it calls for, should I say, something that we have to look at. Is the truth. When you look at the emissions, you realize some concept of climate change and global warming is being perpetrated by some of these things that is being emitted. And also going to the outer space, you find out that there are plenty of debris. Some, should I say, missions have now been trying to be commissioned, which are part of what we're actually looking at, to see how some of these debris can be removed, because some of them can, if not in the near future, can collide with some of these satellites. There are plenty of debris. The question is, even that's why I said we don't have a direct answer, because we are still launching some of these satellites. Countries are now being bragging that, okay, in the next 20 years or the next 5 years, we are going to launch a satellite. That is compounding an already existing compounding system. Because as we are launching them, we are actually making it more crowded. And these are having more of environmental factor, effect on the environment, which sometimes they lead to other, should I say, adverse effects. Then the question is, how do we deal with this? Because it's a trend. Nobody's looking at the impact. It's just going ahead. The question is, who will now come and say, okay, some of these satellites, we should be able to say, this is the amount of satellite we should have in orbit. These debris, according to some of the statistics, how do we remove some of them and see that some of these debris don't have an adverse effect on the operation of the satellite? These are questions that I believe there's no answer for now. That's why that question of environmental impact, I believe a body should be commissioned to look at how some of these effects can be mitigated. Thank you.
Perfectly good, sir. I see a future where astronaut training is going to be for the first space vacuum team. There was a question about any future plans to astronaut payload for ASRI. I'm going to say we're working on it. We're sending up a cleaning team. That's going to be South Africa's claim to the space corps.
Can I sneak in a tongue-in-cheek answer that? I mean, man-rating a launch vehicle is a massive undertaking. CLV is way undersized for anything like that. So we're a ways away from an African launch vehicle carrying African astronauts or Afronauts. But CLV technically can put a person in space on a one-way ticket without life support. And there are a number of individuals who I'd like to invite to take me up on that opportunity.
That's quite valid, sir. And I see, those are the questions. How many rockets can we launch? How many people can we put up? And that is what we've associated with the space program. But for our viewers at home, I think the more important question is, what would that benefit our program and us as a country to do that, to put a person on the moon, or to launch an astronaut? Is that what we need right now, or is that what we look at because that is what we see has been laid before us in terms of conquering space? I am of the opinion that South African needs are different than necessarily putting men and women up in space, and perhaps this is what we need to address. What is the outcome that we actually need from these programs? So I know as a scientist we get bogged down with, we just want to see that astronaut and that rocket and that moonwalking vehicle. But if it's not beneficial to the country's objectives, to society's needs, then perhaps that's not where our focus should lie. I'll end it there, and we'll go back to our whole life cycle approach for very, very brief moments. We are almost out of our time, and for our participants, we are going to take questions from the floor as soon as we finish with this last 1-minute session, and I hope you bear with us. I neglected to mention that the session will run obviously to 11 o'clock since we started at 9:30 instead of 9 o'clock. So we're almost there, and we are not hurting for time. Gentlemen, Mr. Mananga, your turn to go.
Yeah, thank you. Just briefly, I think the approach, I agree with the approach of having to approach any space-related projects or programs from a national program point of view. And then such programs are not to be addressed in silos. So which means that we're going to have to have a look at a proper acquisition process where we look at what is required, what is the required operational capability, and then from that we'll be able to look at the economic factors, exactly things like how does that benefit the industry and so on in terms of knowledge that is being generated through the program. And then from then on, we, in the CSR, we believe much more on the discipline of systems engineering, and in which we go through what we call trade studies. We look at what is feasible given the constraints. Constraints could vary from environmental constraints, it could be political, it could be also technological. And then we run through that and then find what is the most feasible solution that will address the required capability that needs to be developed. And then also when we go through the development, we look at what are the available technologies, because sometimes you wish to achieve something, but the technologies that are needed or required in order to implement that, they may not have reached the technology maturity levels which can contribute positively in that. So we look into that, going through each and every step. So you can't just approach it from a single project point of view. You need a whole program management from a national point of view that looks at all the stakeholders' requirements. Stakeholders could be political, as I indicated, technological, and could be the defense and so on. So that is what I think we must advocate, to have a national program that looks into the, it will take all these factors into account.
Into account, the life cycle approach. Thank you, sir. Mr. Cleophas, very briefly.
Colonel Zama, this now reminds me of when we started off with the Border Management Agency in South Africa. Everybody was doing their own thing for very long. I mean, SARS and this and that. So we're there. And where we are now, there is eventually this Border Management Agency. In the same way, you know, sending up a rocket or sending up a person to space is not necessarily the entire space ecosystem. It's dealing with the subsequence of that, dealing with everything that goes with it, hence the risk models. And I echo what Biko just said. You know, if you do not have an integrated space plan, you will face problems, because you're going to have private sectors pulling in one direction, government pulling in another direction, and the regulator not being ready for all of this. So, I mean, one of the fundamentals that we spoke of earlier, there's no policy in place. The regulator for spectrum is sitting to my right and saying, but I'm trying to get the spectrum in order to enhance the economy. But the political principles are saying, but what are you guys talking about? And hence the suggestion of an integrated space planning commission that will actually critically look at all the aspects as well as the risks, and then subsequently whatever we send up eventually needs to come down. How do we deal with that?
Amen. What goes up must come down. Important. Thank you, sir.
Okay, thank you very much. Yeah, you know, as it was said, the space truly is congested and contested, and there will still be more satellites being launched. So I think one of the solutions, you know, is reusability, and I think our ASRI, you know, KZN guys will need to look into that, you know, because with reusability, you take it up, like you said, goes up, then you can bring it down, you know. And then, because I talk about, you know, the environmental impact, you know, on these systems. So because of the space debris, we can, I think it's been mandated, you know, for satellites to have a DOPD mechanisms, you know, so that when the satellite comes to the end of its life, you can be able to DOPD it, you know. And then the third one will be, it's open opportunities, you know, for engineers and innovators to come up with debris removal mechanisms, you know, and so that's some of the things we can look into, because with every challenge, you know, that's opportunity for people to innovate, you know. Yeah. And then touching on that one of whether should we have astronauts, you know, launching them now, I think that one, our approach should be, it's a progression, you know. Let's launch our satellite first. Let's have our launchers and move to heavy launchers, you know. Then we can say, now we've got heavy launchers. We can be able to build spacecraft and then, you know, put our astronauts in space.
It's developing. Yeah. It's developing.
Yeah. I think just to contribute a bit, obviously for me, it's a question of what are we trying to solve in space? What is the problem statement? Because if within the value chain, we can then define the problem, it becomes easy, even from a regulation, to come up with a framework that is not going to be restrictive, because when it comes to reuse, debris, the question is, must we start looking at lifespan? Must I prescribe and define that anyone who launches as a regulator of the future, must we be prescriptive in terms of lifespan? For me, those are the issues that needs to be looked into. But the big issue is, if we have to take me from Butogwa in my village to the moon next time, what is the purpose? And I think from a cultural point of view, Africa, as you know, there are a lot of things that needs to be still investigated from a research point of view. As long as we can define our contribution within space with a purpose of solving a problem, it becomes easy for a regulator to advance that economic growth in any country. Thank you.
Thank you very much, gentlemen.
I think this is exactly what I was alluding to. We do have organized committees within the indigenous launch capability, And separate to that, there are other steering committees that looks at the general space programs in terms of the satellite systems. But as one big coordinating organization to look into the entirety of the whole system, there isn't, as far as I understand, and I believe that the value will come in if we have that one organizing function that you describe.
Thank you very much. I have time for just one more question. Otherwise, oh, I saw two hands simultaneously. I'll go one. Is that okay? That'll be our one final question. Thank you, sir.
Okay, my name is Rowan Naidu from Strategy and PwC and the University of Cape Town. So my question is, how can we foster partnerships with foreign companies and space agencies to help us develop our indigenous capabilities, even though it might go against their financial interests, since it would be beneficial for them to keep us as consumers?
Thank you. I think we'll direct that to Professor Pato, who started us off on the indigenous concept and partnerships, if you could take that one.
That's a painful question to answer. It's a really good question. You know, the space agencies on paper are all about discovery and leading social change and human endeavor, but every single space agency is going to bat for their local industry. And you've got to, I think, based on some of my experience, you've got to move into pretty dubious circles to short circuit that instinct to kind of protect the local industry, and you pay through your teeth. Trust me. If I can just track back to the matter of formulating guiding foundations and groups for developing indigenous tech, wherever it is on the spectrum. Actually, something that doesn't come up about CLV very often is that CLV wasn't just thumb-sucked. It's actually the outcome of a task team study commissioned by the DSI. Wide-ranging task team took over a year to arrive at a techno-socioeconomic study. So we've shown it can be done. I mean, that was done several years ago already. And I think we need to be flexible about how we go about dealing with certain capabilities. Maybe not having one mothership looking after calling shots, over the whole scene. Be a bit flexible and trust industry as well, trust academia. They know what they're talking about. That's where I'd end that one.
Thank you very much.